This is the LEAP Interim 1 practice. It's on course. It's named LEAP Interim 1 practice, no calculator. This is a part for which you do not use a calculator. Okay, now let's look at this first problem. It says the triangle below is reflected about the y-axis and then translated 4 units to the left. Well, before we do anything to it, let's check to see what it's asking us. The resulting triangle is triangle A prime, B prime, C prime. What is the measure of angle C prime? Okay, well, C and C prime would be corresponding. Okay, so what we're looking at here is finding out what C prime would be. We know no matter what transformation you do on a figure, if they are congruent or if they're similar to start with, or you're doing a transformation on them, the angles do not change. Okay, let's look at this. A reflection, a translation, these are both congruence transformations. The angles do not change. So whatever the measured angle of angle C is going to be congruent to angle C prime. We just need to find the measure of this angle. This box means this angle is 90 degrees and this is 35. The 3 angles in a triangle add up to 180. So add 35 and 90, you get 125. And say 180 minus 125 to get the measure of that angle. And you should be able to, let's see, this is 7. So this would be 10 minus 5 is 5. 7 minus 2 is 5. Okay, so this angle here is 55 degrees. So the measure of angle C prime would simply be 55 degrees. Okay. Now let's look at problem 2. Neptune makes a complete orbit around the sun in about 160 Earth years and travels at 4 times 10 to the 9th kilometers to complete a single orbit around the sun. Approximately how many kilometers does Earth travel in 1 Earth year? Okay. Neptune makes a complete orbit around the sun in 160 Earth years, okay, and travels, let's see, it goes 4.4 times 10 to the 9th in 160 Earth years. Okay, so how far would it go in 1 Earth year? You can even set up a proportion. Essentially, all you're doing is you're dividing 4 times 10 to the 9th by 160. Okay, now, could cross multiply, you get the same situation. So let's divide 4 times 10 to the 9th by 160. I've got 4 times 10 to the 9th. Let's convert this to scientific notation. That would be 1.6 times 10 to the, well, let's see. I'm moving it 2 places. All right, so, and it's a big number, 1.6 times 10 to the 2nd. When we're dividing, we're going to collect like terms. I've got 4 divided by 1.6 times 10 to the 9th divided by 10 to the 2nd. 4 divided by 1.6. I'd say 1.6. How many times will 1.6 go into 4? Okay, it won't go into 4, but it would go into 40. If I do that 2 times, let's see, 2 times 6 is 12. 2 plus 1 is 3. Okay, subtract, you've got 80. You move both of those, actually. Okay, how many times will 16 go into 80? Let's see. 16 will go into 80. Let's try it. 16 times 6 times 6 is 36. That would be 96. No, that's too many. 16 times 5. 6 times 5 is 30. That's 5, 6, 7, 8. Okay. So that would be 5 times. 2.5 times. Okay. So we're going to substitute 2.5 here times 10 to the, whenever you're dividing and you have the same base, you subtract your exponents. 9 minus 2 is 7. 2.5 times 10 to the 7. Okay. Let's look at number 3. Which series of transformations shows that figures 1 and 2 are similar? Well, in each one of these, we're starting with figure 1. If we're going to make it to figure 2, we need it to be smaller. Our scale factor will be a fraction. The difference between these here is whether it's 1/2 or 1/4. Let's find two sides that correspond, because we know our scale factor will be equal to the length of the image side over the pre-image. Okay, we're starting with 1, so this is our pre-image and here's our image. Let's find corresponding sides. I know this side here is on grid line, so it's perfect to use, and it's 1, 2, 3 units long. And this side is 1, 2, 3, 4, 5, 6 units long. Okay, so our image over our pre-image is 3/6. The scale factor is 1/2. So this is not a right answer, and this is not a right answer. Dilation of figure 1 with a scale factor of 1/2, then a rotation in translation, or a reflection in a translation. Well, if I rotated this long side would be up at the top. Okay, let's see if we rotated this. First, we got to dilate it by a scale factor of 1/2. This is at -2, 0, so that would be -1, 0. This is at 0, -4, so that would be 0, -2. This point is at -6, -4. Half of that would be -3, -2. Okay, so if I have dilated it by a scale factor of 1/2, it looks like this. Okay, if I rotate it, this long side's going to be up. Okay, if I rotate it, you're going to wind up with this point here, this point here. So you put it on tracing paper, and up 1, 2, 3. Okay, it's going to look like this. Put it on your tracing paper, and then all I got to do is translate it. So I rotate it and translate it. Dilate it by a scale factor of 2, then rotate it and translate it. Here's your answer. Let's go to problem 4. One estimate of the number of cells in the human body is, and it's shown here. What's closest to that number in scientific notation? Well, if I round this 38 to 40, because all of those are 4, I've got 40, 1, 2, 3 zeros, 1, 2, 3 zeros, 1, 2, 3 zeros, and then another 1, 2, 3, right? 1, 2, 3, 4 groups of, okay. Now let's see how far we'd move our decimal to get it behind the 4. I'd move my decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 4 times 10 to the 13th power. On 5, the average weight of a bug is about 6 times 10 to the -7 grams. Which number shown below would be the approximate weight of an average bug? Okay, times 10 to the -7th means it's a very small number, so it's not this one, and it's not this one. What we've got is 6, and we're moving it to -7 place. If you'd start there, okay, 1, 2, 3, 4, 5, 6, 7. Okay, I need behind the decimal 1, 2, 3, 4, 5, 6 zeros. Behind the decimal, I need 1, 2, 3, 4, 5, 6 zeros before I get to the 6 or to the 5.8, right? Here's your answer. In the figure shown below, select all of the line segments that can be generated by rotating, reflecting, or translating figure A. If you start with figure A, you rotate, reflect, or translate it, it's going to be the same length as figure A. Whatever the sizes are will all be the same length. C is longer, it's not C. B is shorter, it's not B. D is shorter, it's not D. E is longer, it's not E. A is not, F is longer than this one, it's not that. G would work, okay? G and A, you could draw this off even if you wanted to. I is too short. H would work. So G and H would be the right length to actually be one of these. These are congruence transformations. That means A is going to be the same length as those. Look at number 7. Select all of the following that would be equivalent to 1 over 5 to the third. We know 1 over 5 to the third is the same as 5 to the negative third. Okay? So we want everything that would be 5 to the negative third. I'm raising this power to a power, so I multiply the exponents. That would be 5 to the 1 times negative 3, or 5 to the negative 3. So this one works. This one is 5 to the negative 3. If I have the same base and I multiply, I add the exponents. That would be 5 to the negative 1 plus negative 2, or 5 to the negative 3. This one here is just simply 1 over 5. 5 times 5 times 5 is 5 to the third power. 1 over 5 to the positive third power. So this one doesn't work. Okay? And this would be 5 to the positive third power. So that doesn't work. Okay? And this one would be 1 over negative 5 raised to the third power, because that's negative 5 times itself 3 times. Okay? Look at number 8. On the coordinate plane below, square ABCD is dilated by a factor of 2, with the origin as the center, to form A prime, B prime, C prime, D prime. After the dilation, what's the location of C prime? Okay, if it's dilated by a scale factor of 2, we need, and we're looking for C prime, we need the coordinates of C. It's at 2, negative 3. C is at 2, negative 3. Okay? We dilate it by 2. We're looking at a C prime that would be 4, negative 6. 4, negative 6. Okay? Each year, the Earth travels about 940 million kilometers to complete its orbit around the sun. At this rate, how many total kilometers would the Earth travel to complete its orbit over a 30-year span? 940 kilometers in 1 year. We want to know how many in 30. So 940 million times 30. Okay, we can do this way if we want to, or we can do it as scientific notation. Let's go ahead and do it just normally, and then we'll do it as then we'll look at it otherwise. If I've got this and I'm multiplying it by 30, 940, 0, 0, 0, 0, 0, 0, times 30, okay? Well, there's a 0 here, you put down a 0. Now, 0 times 3 is 0. 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 3 times 4 is 12. Carry your 1. 9 times 3 is 27. Plus 1 is 28. Okay? Now, these are all in scientific notation, so let's express it as scientific notation. We know we have 1 digit in the front, followed by a decimal. It can't be a 0. It's got to be 1 through 9 in the front. We're moving our decimal place. This is a big number, so it's times 10 to the, and it's going to be a positive number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times 10 to the 10th. When it's a positive exponent, it's a big number. When it's a negative exponent, it is a decimal. Okay? 2.82 times 10 to the 10th. Number 10. Oops. Number 10. On the coordinate plane below, figure 1 was transformed twice to form figure 2. Okay, which of the following cannot be the two transformations? All right, let's see what we've got. A reflection over the y-axis. Okay, if I reflect over the y-axis, it's going to look like this. So that's 1 point from. This is 1, 2, 3, 4, 5 from. 1, 2, 3, 4, 5. And this is 1, 2, 3 from. So 1, 2, 3. That's a reflection over the y-axis, followed by translation. That won't work, will it? Reflection over the y-axis, followed by translation. That one is the one that will not work. Okay, let's look at number 11. On Tom's calculator, a number that can't be displayed in 10 or fewer digits is presented in scientific notation. Tom's enters a multiplication problem, and here's the answer. What's this number in standard notation? The E means times 10 to the. This 7 times 10 to the 11th. Now, they want this in standard notation. When I'm multiplying by something times 10 to the 11th, I'm moving the decimal 11 places. There's an understood decimal there, so I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, got 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, those are first three. Here are my second three. Here are my third three. 0, 0, 7. Okay, I've got 3 batches of those and 700 in the front. 700 and then 3 batches of the 3 zeros. There we go. Let's look at number 12. A calculator shows the answer to a division problem is 3.5 e to the negative 7. Remember, e means times 10 to the. All right, so this is 3.5 times 10 to the negative 7. Okay. This one says the coordinate plane below shows the location of parallelogram EFGH. If it's rotated 90 degrees clockwise, it's going to be one turn this way. After the rotation, what's the location of vertex H? Okay, well, draw this on patty paper, put your pen right here and rotate it around. And if you do this, you're going to find that it is on -2, 9. Okay, the point's actually going to be on -2, 9. I'm sorry, -2, -9. It's going to be right down here, -2, -9. All right, that's where your H prime will be if you rotate it around. The committee in charge of a music festival is planning the event. The figure ABCD shown on the graph below represents last year's placement on one stage area in the park. This year, the stage is to be translated down 4 units. Translated down 4 units, and then reflected across the y-axis to form A prime, B prime, C prime, D prime. After the transformation, what will be the coordinates of point B? Okay, let's translate B 4 units. I'm just going to do point B because that's all that matters. I'm going to translate it 4 units down. 1, 2, 3, 4. Okay, that's where we translated it down. Okay, now reflected across the y-axis. Here's the y-axis. Let's see how far we are from the y-axis. We are 1, 2, 3, 4, 5, 6 on the side, so we'll be 6 on the other side. 1, 2, 3, 4, 5, 6. Okay, this is -6, 1. Angle ABC is rotated 125 degrees around point C to generate angle A prime, B prime, C prime. The measure of angle ABC is 60 degrees. What's the measure of angle A prime, B prime, C prime? If I'm doing a rotation is a congruence transformation. The angles do not change. Hence, the measure of this angle before or after that rotation is 60 degrees. Company A has a monthly budget of 2 times 10 to the 4th dollars. Company B has a monthly budget of 5 times 10 to the 8th dollars. How many times greater? Times greater. How many times greater? We talked about this. If it says how many times greater is something, what do? What if you have the big heavy kid, okay, who weighs 200 pounds, and you got the little bitty kid who weighs 100 pounds, okay? How do I figure out how many times heavier this kid is than that one? I would divide the 200 by 100, okay? And it would tell me he's 2 times bigger, right? So when we say how many times we are dividing, how many times greater, you put the bigger one on top. Times 10 to the 8th gives you is the bigger one. 10 to the 4th is a smaller one. 5 times 10 to the 8th divided by 2 times 10 to the 4th. Now, let's split these up. Let's collect like terms. This is 5 divided by 2. See, I've got the numbers in the front. And now let's put the bases and the exponents this way. 10 to the 8th divided by 10 to the 4th. Oh, wait, this is times. 5 divided by 2 is 2.5 times. And whenever I've got 10 to the 8th divided by 10 to the 4th, I have the same base. So I subtract the exponents because I'm dividing. That would be times 10 to the 8 minus 4 would be 4. 2.5 times 10 to the 4th. Well, let's change that because all of these are in standard form. I need to move this 4 places. That's 1, 2, 3, 4. That's 25,000 times greater. Okay? Noah transformed figure 1 to obtain figure 2. Then he transformed 2 to obtain 3. Which transformations can be the ones Noah used? Okay? To get from 1 to 2, what did we do? We reflected across the x-axis, okay? So we got 2 that say it could be a reflection across the x-axis. Not this one, not this one. Okay? So reflected across the x-axis. And then 2 looks like 3, so then we're going to translate left, okay? So reflection across the x, and then a translation left. Number 18, select all of the following that are equivalent to 3 to the 8th power. Okay? If I'm multiplying here and I have the same base, I add my exponents. That's 3 to the 2 plus 6, or 3 to the 8th power. This one is right. 3 to the negative 6 times 3 to the 14. Okay? If I'm multiplying and I have the same base, I need to add the 2 exponents. That would give me 3 to the 8th power. 3 times 8, 8 times 3 is 24. That has nothing to do with this. 1 over 3 to the 8th, the other way I could express that is 3 to the negative 8. So that's not what we're talking about. We're talking about 3 to the positive 8th power. When I raise a power to a power, I keep my base and I multiply my 2 exponents, 2 times 4. So that's 3 to the 8th power. That's what we're looking for, 3 to the 8th power. Okay, in this case, I'm multiplying and I have the same base, so I add my exponents. That would be 2 plus 4. That's 3 to the 6th power, not what we're looking for. Here I've got 3 to the 1, 2, 3, 4, 5, 6, 7, 8th power. There's 3 to the 8th power. Okay, all of those are equivalent. Now let's look at number 19. Triangle ABC is reflected over the x-axis to generate figure A prime, B prime, C prime. So we got a reflection. Figure A prime, B prime, C prime is rotated 50 degrees clockwise around the origin to create figure A double prime, B prime, double prime, C prime, double prime. Which of the following statements about this first triangle and the last triangle are true? Well, we had a reflection and a rotation, so all of those are congruence transformations. So all of the figures are congruent, right? Okay. The triangle shown on the grid below has these vertices. Suppose triangle A prime, B prime, C prime is a triangle that results from reflecting this triangle about the x-axis, reflected over the x, and then translating it 2 units to the right. Plot point B prime on the grid. So let's just take A prime. So let's just take A, which is -1, 4. Let's see, -1, 4. Here's our A. They want us to reflect it over the x-axis. Here's the x-axis. This is 4 units above. So when I reflect it, it's going to be 1, 2, 3, 4 above. It's 1, 2, 3, 4 below. Okay, there's the A prime. Okay. Then translate it 2 units to the right. Okay, 1, 2. This is where it would actually be plotted, right there. Okay. It's not A prime. This is A prime. We had to do both transformations to get us there, didn't we? Let's look at number 21. A scientist observed a bacterium in a microscope. Here's what it measured. Which of the following is closest to that? Well, let's look at this, guys. 29. Isn't that close to 30? Was it 1, 2, 3, 4, 2, 3, 4, 5? And let's replace this 29 with 30 because it would round to 30, wouldn't it? Okay? All right. This is actually, let's move our decimals. Let's make sure we can see these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 3, 0. This is going to be equal to, now we need our decimal place to be here, don't it? 3 times 10 to the -1, 2, 3, 4, 5, 6 place, right? And it's negative because it's a number that's less than 1. It's a very small number, and we're not counting just the zeros. We're counting the number of places we're moving it. Why is it 3 and not 2? Because 29 would round to 30 and not 20, okay? So it's 3 times 10 to the -6. Let's look at 22. Red blood cells are usually about 8 times 10 to the -6 meters in diameter. What's that number written in standard notation? Okay. Times 10 to the -6 means it's a very small number. Okay. We know that regular decimal's right here behind an 8. So we're going to move it 6 times to make it smaller. 1, 2, 3, 4, 5, 6. Okay. So this is 0.000008. 2, 3, 4, 5, 6. 1, 2, 3, 6. 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros before the decimal. 1, 2, 3, 4, 5 zeros before the decimal. Right there. Okay? And then 23. Andrew drew this polygon on the grid below. Next, he translated it 3 units to the right and 4 units down. Which statement about the sides of the transformed polygon is true? Okay, well, if you did all of this to it, they're talking about the lines that will be parallel. If I start with these 2 lines that are parallel, when I get finished, those lines will be parallel. So we're looking at a UV and an RT. U prime V prime is parallel to R prime T prime. Okay? There's our answer. And I think that covers all of them. So let's stop